Session, we are going to discuss access specifiers or access modifiers in C#. So what we are going to discuss in today's session? First, we will discuss what are exactly access specifier or modifiers in C#. What are the different kind of access specifiers supported in .NET Framework? Then we will understand what are exactly type and type members. And then we will understand what are exactly private, public, protected internal, and private protected access specifier with examples, right? So in .NET Framework, we have 6 different kind of access specifier, and we will understand all these 6 different kind of access specifier with examples in today's session, right? So the first question is, what are access specifier? See, before understanding access specifier, we need to understand what are keywords. So whenever you are developing any kind of applications, right, whether you are developing the application using C# or using Java or using C++ or in any kind of programming languages, each programming language is having some keyword. Keyword means they are fixed word. Their meaning is fixed. You can use that keyword for that particular purpose. You cannot use the keyword for other purposes. Even you cannot use the keyword for your identifier, right? So every keyword that we use, such as private, public, protected, virtual, sealed, partial, abstract, static, base, all are called modifiers in C#. Then what are access specifier or access modifier? The access specifier or access modifier are special kind of modifiers which we use to define the scope of a type and the type member, right? So what it means, right? So out of all these modifiers, which modifier are used to define the scope of a type? Which modifier are used to define the scope of a member, right? So those modifiers we are going to call as access modifier or access specifier. So in simple words, we can say that access specifier are used to define the scope of the type. Whenever I'm saying type, it might be a class, it might be an interface, it might be unstruct, delegate, enums, or etc. So it is going to define the scope of the type as well as the scope of their type members. Within a class, you can define variables, you can define properties, you can define constructor and method. So what is their scope of the variable? What is the scope of the properties, right? What is the scope of the constructor? What is the scope of the method? All these things are going to be defined by the access specifier that you use while creating the members, right? So scope means accessibility or visibility. What it means? Now it means who can access them and who cannot access them are going to be defined by the access specifier that you use when you are defining either the type or while defining either the type member. See, I have a class. I have created a class with a set of members. Then who can access this set of members? Who cannot access this set of members? Those are going to be defined by the access specifier that we use with the members, right? So what are the different types of access specifier supported in C#? In C#, 6 access specifier are provided, right? So you can use these 6 access specifier in C#. So private, public, protected internal. These 6 access specifier are previously used or introduced, and this private protected it is introduced in 7.2. Right? Members that are defined in a type with any scope or specifier are always accessible within that type. Restriction come into the picture only when you try to access them outside of the type. So what it means? It means suppose you are creating a class. Inside a class, you have created some members, right? Those members you can access directly inside the class. Whether those members you created using private, public, protected, no matter, you can access them directly within the class. That means within the class, there is no such restriction counts. Then what is the use of this? If you can access them directly within the class, there is no such restriction, then what is the use of these access specifier? That you need to understand. See, these access specifier are going to play the important role when you try to access the type and the type members from outside the class, right? Restriction comes into picture only when you try to access the class or when you try to access the class member from outside the class. This is the point that you need to remember. And each and every access specifier or access modifier has a different scope. And we will discuss all these different scope with different kind of examples, right? In today's session, I'm going to demonstrate the example using Visual Studio 2019. Why I'm going to use 2019? Why not the older framework like 2017, older Visual Studio 2017 or 2015? This is because if I'm going to use the older version of Visual Studio, then this access specifier I cannot use, right? If you want to use this access specifier, then you need to use at least Visual Studio 2019 or the higher version like 2020, right? Before understanding all these access specifier in detail, let us first understand what are exactly type and type member. See, whenever you create a class or whenever you create an interface drop enum, those are nothing but your type. So you can see in this example, I'm creating one class. I'm creating the class example. So you can see example is created by using the class keyword. So this example is nothing but it's going to be a type. And as part of this type, whatever member we define, those are going to be called as a type members. You can see within this close, open and close curly braces, I have defined four members. Then these four members are nothing but the type members. And one more point that you need to remember is you can apply only internal and public access specifier to the class to the type. So if you are creating a class, then you can only use either public or internal. You cannot use private, you cannot use protected internal and private protected. Those four access specifier you cannot use with the type. But with the type member, you can use all the six access specifier, right? And one more thing, if you are not using any access specifier for a class, then by default it is going to be internal, and for a class member, by default it is going to be private. With this keep in mind, let us proceed and understand all the six access specifier with example. First, we will understand access specifier with the type members, and then we will understand access specifier with the types. So what I'm going to do, I'm creating one console application using Visual Studio 2019. So I'm opening Visual Studio. Once you open Visual Studio, then click on this create new project option. Once you click on this create new project option, then it will open the project template window. So here I'm going to create a console application. So I just search for the console, and then you will see different options. See, I'm going to use .NET framework and the C# programming language. So I selected this option and then click on the next button. Once you click on the next button, you need to provide the project name. You need to select where you want to create the project. I'm going to create the project in the project directory. Solution name, I'm going to keep the same as the project name, and I'm going to use the latest .NET framework, which is 4.8, and then click on the create button. Once you click on the create button, it will create a console application, and that console application is going to be created with one class file called program.cs class file, right? And now to demonstrate the examples and to make you better understanding, what I'm going to do, I'm going to add another project to this solution. So, and that project I'm going to add is a class library project. See, if you want to add any project to your existing solution, then how you can add? Simply right click on your solution. Once you right click on solution, then you need to select add new project option. So add new project, and what type of project you want to add? I want to add a class library. Search for the class library, right? Once you search for the class library, then you need to search which class library is for .NET framework and using C# language. This is the template, right? This is the class library project which support the .NET framework and the C# programming language. Select this one and click on the next button. Once you click on the next button, then it is going to ask, it is asking you to provide the project details, right? So project details means what is the name of the project, where you will create the project, and what framework you are going to target for this project. So I'm providing the name as assembly one. I'm creating this project inside the same location, right? Access specifier demo, and I'm going to use the .NET framework 4.8, which is the latest one. Once you provide these details, click on the create button. Once you click on the create button, you will see that this assembly one project, I mean the class library project, is added to your existing solution, and this class library project is created with a class file called class1.cs. Now this is one project and this is one project, or you can consider this is one assembly and this is one assembly, right? So whenever you create a console application, one assembly is created, Whenever you create a class library project, another assembly is created, right? And if you want to see what exactly the assembly type, so you just need to build the solution. Once you build the solution, and if you will see that build is successful, the build is successful, then you can only see the assemblies, right? For any console application or Windows Form application, the assembly is going to be an exe, right? If you go to the bin debug folder, you will see that this is your application, right? Assembly type is application. And if you go to the properties, you will see that this application type is .exe, right? So whenever you see any assembly with the extension .exe, means you can run that assembly directly by double clicking on it, right? Now let's see the other assembly. So if you want to check this class library, so this is also going to be created one assembly, but this assembly extension is not exe, it is going to be .dll, right? So you cannot run any assembly with the .dll extension directly, right? Now you might be one question, sir, what is exactly an assembly? So according to MSDN, assemblies are the building block of a .NET framework application. They form the fundamental unit of a deployment. In simple word, we can say that assembly is nothing but a pre-compiled .NET code that can be run by the CLR. For a console application, the assembly is exe. For the class library project, the assembly is DLL. We cannot run a DLL directly, but we can run an assembly with the extension exe directly, right? So what exactly an assembly? So assembly is nothing but it contains the pre-compiled code. Suppose this is one assembly. Inside this assembly, whatever code you have written. So currently we are having only one class file. You might be have multiple class file. You might be have multiple interfaces, right? So whenever you compile the application, the compiled code, right? Compiled code in the sense intermediate language code will be grouped together, and that compiled code you can access from other assembly by using the assembly reference, right? So by using the assembly. So this assembly contains this class one code, right? And if you want to access this assembly code inside another assembly, then you need to add a reference to that assembly. That we will discuss, right? Don't worry, we'll discuss how to add a reference, how to access another assembly classes or interfaces from another assembly. Everything we are going to cover as part of this session, right? Right. So access specifier with the type member. So what we are going to do, first we will discuss access specifier with the type members, and once we discuss access specifier with type members, then we will discuss access specifier with type, right? So access specifier or access modifier define the scope of the type member. So whenever you are creating a class, inside this class you can create any number of members, and while creating the member you need to specify the access specifier. What access specifier you define or you specified for the type member, that access specifier define the scope of the type member. Scope means who can access that member, and who cannot access that member is going to be defined by the access specifier. So first of all we need to define, or first of all we need to understand what are the different scopes for a type member. I mean, what are the different locations from where you can access the type member? The different scope for the type member, or the different location from where you can access the type or type member are as follows. Within the same class, suppose you are creating some data member or member function. Within the same class, you can access it or not. Within the derived class in the same assembly, you can access it or not. Within the derived on the non-derived class in same assembly. See, here we need to understand what is same assembly and what is other assembly, right? So whenever we define a class with, so here we need to understand these five things. Five things means within the class, am I able to access the member or not? Within the derived class in the same assembly, am I able to access the member or not? Within the non-derived class in the same assembly, am I able to access the member or not? Within the derived class in other assembly, am I able to access the member or not? Non-derived class in other assembly, am I able to access the member or not? All these things are going to be defined by the access specifier that you use for your member, right? Now, based on the access specifier, the restriction is applied to the type member. Now, let us understand what are the different access specifier and how you can use them and how you can restrict them All those things, let us try to understand one by one. Let's start the discussion with the private access specifier or private or you can say private access specifier or private access modifier. So when we declare a type member, so whenever I'm saying type member, you can declare all these things with the private access specifier, then we can access that member within the class only. From outside the class, we cannot access them. So to make you understand what I'm going to do, I'm just copying this code and I'm just pasting this code inside the class one file of the class assembly one class library project. This is your assembly one. So this is your class library project. This class library project, I'm so having one class file that is class1.cs, and within that class file, I'm creating three classes. One is this is the class, this is the second class, and this is the third class, right? Inside this class, I have created one data member, or you can say a member, or you can say one variable with the private access specifier, right? If you declare a variable as private, or if you declare any member as a private, then you can access that member only within the same type. So within the type means where it is created, only you can access within the type of it. So this variable is created inside this assembly one class one. What it means? Now it means you can access this variable only within this class. So see here I'm creating one method, and within this method I'm able to access this variable. I'm not getting any compile time error. But this is the derived class within the same assembly. Same assembly. See, whenever I'm saying same assembly means within this class one assembly one project. And if I'm saying different assembly, if I try to access this class from this project, means this project is this assembly is another assembly, and this is a different assembly. If you try to access from a different assembly, that is a different story altogether. That we will see. But for now, we are trying to access this variable within the same assembly. Same assembly within the derived classes, and this is the non-derived classes. So see, this assembly one class 2 is a derived class of this class, but even though it is a derived class, you cannot access the private data member. And from non-derived classes, you cannot also access the private member. So what it means, the private members are only accessible within the type where it is created, right? Now if you look at the other examples, right? Other examples means now what I'm trying to do is, now I'm trying to access this class, right? This class from a different assembly. From a different assembly means this assembly is nothing but your class library project, and I want to access the classes which is created inside this class library project, that is inside this assembly one from a different assembly like access specifier demo. Then what will happen? See, first of all, this is the so inside this class I'm creating one class, two classes, and three classes. But here I'm trying to make an inheritance relationship with this class. But if you remember, this class is created in a different assembly. And whenever you create a class in a different assembly, and if you want to access that class, first of all, you need to add a reference to that class. See what I'm getting error. The type or namespace assembly could not be found. Are you missing using a using directory or an assembly reference? Yes, this class is created in a different assembly. I have to add the reference to that assembly. How you can add? So to add the reference, so just you need to expand the reference folder, right click the reference folder and click on the add option. Once you click on the add option, then you have assemblies, project, shared project, com and browse. You need to select the project, and inside this project, you need to add a reference to this assembly, right? So just check the checkbox and click on the OK button. Once you click the OK button, then that reference you can see added here, right? Once you add the reference, then you need to use the using statement, right? Using the assembly one. So what is assembly one? This is the namespace name. So you need to add the namespace using assembly one. Once you add this, then you will see that the error which you are getting previously is gone. But you are getting this. Even though this class is derived from this class, we are getting this here. So what it means, you cannot access the private member from the derived class from other assemblies. You cannot access the private member from the non-derived classes from the other assembly. So here we are also getting the error. So to summarize these things, what we can say that to summarize these things, if you declare a data member as private, then within the class you can access it. From the derived class in the same assembly you cannot access it. From the non-derived classes in the same assembly you cannot access this. From the derived class in other assembly you cannot access, and from non-derived class in other assembly you cannot access this. Then where you can access the private member? Only within the class. This is about private data, private access specifier. Now come to public access specifier. When we declare a type member, whether it is a variable, property, method, constructor as public, then we can access that member from anywhere. You can access that member from anywhere. That means there is no restriction for public member. Let us understand this. So what I'm going to do, I'm just changing this private to public. Once I make this as a public, then you will see that there is no compilation error. So you can access that member directly from the derived classes. You can access that member by using the object from non-derived classes. This is, we are not getting any error. So we can access the private data member from the derived classes, from the non-derived classes of the same assembly, right? There is no error, no compilation error. Now coming to the other assembly, this is our other assembly. This is our console application. You can see, even though the member is, see, the point that you need to remember, this is public. As you make it as public, it is accessible everywhere within the same assembly as well as from a different assembly. This is your different assembly, and you can see I'm making the inheritance relationship, and there is no inheritance relationship. This is your derived classes. This is your non-derived classes. From the non-derived classes, we are accessing the member. From the derived classes, we are also accessing the member. That means once you declare any member as a public, then you can access it from anywhere. So the scope of the public member in C# are as follows. Within the class, yes, we can access. From derived classes, same assembly we can access. From non-derived classes in the same assembly we can access. From the derived class in other assemblies we can access. From the non-derived class in other assembly we can also access. From anywhere we can access it. Now let's come to the next access specifier, that is protected access specifier. Protected members in C# are available within the containing type as well as to the types that are derived from the containing type. That means protected members are available within the parent class as well as to the child classes derived from the containing type. It doesn't matter whether the derived class is in the same assembly or in a different assembly, you can access it. Let us understand this with one example. Okay, so what I'm going to do is I'm just changing this to protected. So as soon as I make the variable as protected, you can see from the derived classes within the same assembly, I can access it. I'm not getting any error. But from the non-derived classes in the same assembly, I'm getting the compiler error. So what the compiler is saying, assembly1 class1.id is inaccessible due to its protection level. So you cannot access this member from a non-derived class within the same assembly. But from the derived class within the same assembly, I'm not getting any error. Within the same class I'm accessing, I'm not getting any error. Now come to the other assemblies, right? From the other assembly, I'm just making an inheritance relationship. So this is other assembly, derived classes, I'm not getting error. But from the other assembly, non-derived classes, I'm getting the error. So what it means if you declare any member as protected, then you can access that member within the type where it is declared, within the derived classes of the same assembly, and within the derived classes from other assemblies. So these three places you can access the protected data members. Now, if you go to the summary, you will see that what is the scope of protected members means within the class. Yes, we can access. From derived class in same assembly, yes, we can access. From non-derived classes in same assembly, no, you cannot access. From derived classes in other assembly, yes, you can access. From non-derived class in other assembly, no, you cannot access. So this is all about protected members within the same class, within the derived classes. It doesn't matter whether the derived class is in the same assembly or in different assembly, right? Now, next access specifier is internal access specifier. Whenever a member is declared with the internal access specifier, then it is available anywhere within the containing type. It's a compile time error to access an internal member from outside the containing type. Let us understand this with an example. See, what I'm going to do, instead of protected, I'm changing this to internal. So as I make this internal, you can see this is the containing assembly. This is the same assembly, right? Within the same assembly, within the same class, within the class, I'm able to access the member. Within the same assembly derived classes, I'm able to access the member. Within the same assembly non-derived classes, even I'm able to access the member. But if you now come to the other assembly, this is our other assembly. In other assembly, you can make the inheritance relationship, but you cannot access the you cannot access the internal member, right? Even you cannot access the internal member. So it doesn't matter whether the class is inherited or not, whether it is a derived class or a non-derived class. If the class is in a different assembly, then you cannot access the internal member. And if the class is within the same assembly, then you can access it directly, right? If it is a derived class, and you can access through the object if it is a non-derived class, but you cannot access from a different assembly, right? You can see. So now coming to the summary point, what we can understand is, so if the scope of the internal member as follows: within the same class, yes, you can access. Within the derived class in same assembly, yes, you can access. Within the non-derived class in same assembly, yes, you can access. Derived class in other assembly, no, it's an internal member. You cannot access the internal member from other assembly. It doesn't matter whether it is a derived class or it is a non-derived class, but if it is other assembly, then you cannot access the internal member, right? Then the next access specifier is protected internal access specifier. So what it means? Now, protected internal members or protected members or protected internal members can be accessed anywhere within the same assembly, that is in which it is declared, or from within a derived class from another assembly. So we can think it is a combination of protected and internal access specifier. So what do you mean by protected? Protected means you can access it within the same class and from the derived classes. That derived classes may be in the same assembly or maybe in a different assembly, no matter. What it means, internal means you can access the member from anywhere within the containing assembly, right? So let us understand this with an example. So what I'm going to do is, I'm just making this as protected internal. I'm just making this as a protected internal. As soon as I make it as protected internal, you can see within the same class I'm able to access it. Within the derived class in same assembly, I'm able to access it. Within the non-derived class of the same assembly, I can able to access it, right? But now come to the other assembly. In other assembly, if you are making the inheritance relationship, and then it will become a child class, it will become a derived class. From the derived class, you can access the member. But from the non-derived class, you cannot access the protected internal member. This is the thing that you need to remember. It is the combination of protected and internal. Internal means within the same assembly. Protected means from the derived classes, right? So this is the different assembly derived classes I'm able to access, but a different class non-derived classes I'm unable to access. Within the same assembly, within the derived class and within the non-derived class and within the same class, I'm able to access the protected internal member. Now, if you go to the summary part, yes, within the class, we can access the protected internal member. Within the derived class, non-derived class, in the same assembly, yes, we can access this. This is because of the internal access specifier, and derived class in other assembly, yes, we are able to access because of the protected. From the non-derived class, we cannot access, right? From the non-derived class, other assemblies we cannot access, but the non-derived class in same assembly we can access, right? Now the last access specifier that you can apply to a type member is private protected. So what it means? The private protected members are accessible within the class and within the derived class of the same assembly, but cannot access from other assembly, right? Now if you look to this, so what I'm going to do, I'm just making this as a private protected, right? As soon as I make this variable as private protected, within the same class I'm able to access it, This is because of the private and protected means within the same assembly derived class. This is the derived class, and this is the private means it is private. You can access it only within the class. Protected means you can access it within the derived classes, right? Within the derived classes. So this is the derived class. You can access it. But as it is not only protected, it is private protected. You cannot access this from the derived classes from other assembly. Other assembly derived classes you cannot access. So what exactly the private protected means? Private protected means you can access within the same class, within the derived class of the same assembly. You cannot access this member from the non-derived classes, and you cannot access this member from the other assemblies. From other assembly, you can see other assembly derived class, other assembly non-derived class. You cannot access. You are getting some compile time error. You can see the red symbol here. So this is all about the access specifier that you can apply with the type member. Now to summarize this, what I can say, see, this is the private protected member. Within the class, yes. Derived classes in same assembly, yes. All other places, no. Right? Now, if you want to summarize the access specifier with a type member, then you need to observe this diagram carefully. This is the member. This is the type member you created with the public, protected, internal, private, protected, and private. Within the class, this public member is accessible. Within the derived class, non-derived class, derived class, different assembly, non-derived class, different assembly, public member are accessible everywhere. Protected internal means you cannot access the protected internal member from non-derived classes which are in a different assembly, but all the four places you can access the protected internal member. And coming to protected, see, first of all, it doesn't matter which access specifier you use within the class, everything is accessible. You can see within the class, every access specifier you can access. Restriction only comes when you are accessing from the other classes. So for the protected member, you can access it only from the derived classes. That derived class may be in the same assembly or may be in the different assembly. You can see, you can access. But from the non-derived classes, whether it is in the same assembly or whether it is in the different assembly, you cannot access. Coming to internal means within the containing assembly. Containing assembly means within the same assembly, within the same class, within the derived class in same assembly, non-derived class in the same assembly, you can access. But you cannot access from outside the assembly. Whether it is a derived class or whether it is non-derived class, that doesn't matter. You cannot access the internal member. Coming to private protected means you can access within the class and we can access the derived class within the same assembly. Rest three places you cannot access the private protected member. Now, the private means only within the class, right? You cannot access from outside the class. This is all about your access specifier with type member. Now we can see access specifier with the type in Caesar. So we can use all 6 access specifier with the type member, but type allows only 2 access specifier, that is internal and public. It is a compile time error to use private protected internal and private protected access specifier with type. If you try, then what you will get? You will get this error message which I am showing in the red column. Elements defined in a namespace cannot be explicitly declared as private protected internal and private protected. So these 4 access specifier you cannot explicitly define inside a type or inside a namespace directly. Then what are other available? Only public and internal. Only public and internal you can use directly inside a namespace, right? So to make you understand, what I'm going to do is I'm trying to make this as a private. So once I make this as a private, you will see one error. What error it is showing? Now it is saying elements defined in a namespace. You can see elements defined in a namespace cannot be explicitly declared as private protected internal and private protected. So this is our namespace. Inside a namespace, you cannot use this private access specifier directly, right? So not only this private access specifier, you cannot also use protected internal and private protected. Suppose I'm trying to use the protected here. Okay, protected, again I'm getting the same error. But if you use public, then you will not get any error. If you use internal, then also you will not get any error. So the only allowed access specifier for a type is internal and public, right? So now what I'm going to do is, if I'm making this as internal, right, then what are the things it's going to be happening, right? If you make this as internal, then you can access that within the same assembly only. So this is the assembly. So if you make any class as internal, then within the same assembly you can access it, right? Okay, let me do one thing. Let me change this to public so that I can access it from anywhere, right? Even though we make it as public, see, the class access specifier is internal, right? As this is internal, you can make the inheritance relationship within the same assembly. You can create an instance of that internal class within the same assembly only. Now we are making that class as internal. Now come to our other assembly. Other assembly, we are referencing to that assembly. We are using the using statement, but we cannot make an inheritance relationship. Why? Because inaccessible due to its protection level. So once you create any class which internal access specifier, then from other assembly you cannot access. You cannot make inheritance relationship. You cannot create an instance of that class. This is the thing that you need to understand. But if you make the class as public, suppose I'm making this class as public, then what will happen? Within the same assembly you can access, you can make the inheritance relationship, you can create an instance from a non-derived class. Even though you are accessing from the same assembly, you can also access this class from a different assembly. Now come to our different assembly. This is our different assembly. You can see I'm making the inheritance relationship. Yes, inheritance relationship is possible because this class is now available. Why it is available? Because it is now public. And you can say even you are also able to create an instance. Why you are able to create an instance? Because this class is public now. Public means you can access it from outside the assembly. So this is all about access specifier that you can use with class and a class member. Now suppose someone asks what is the default access specifier for a type. So you can, if you remove this, then what is the default? Now, so as soon as I remove this internal keyword, then you will see from other assembly I'm getting the error. If I'm making the class as internal, what error I'm getting? If I'm removing any access specifier, if I'm not providing any access specifier, I'm also getting the same error. What it means? It means by default, it is going to be internal, right? Then what is the default access specifier of class member? The class member default access specifier is private. See, this is the derived class. From the derived class also you are unable to access. Why? Because it is private. So default access specifier for a class is internal and the default access specifier for a class member is private. That's it. So that is all about your classes, your class members with access specifier.